Well, this talk really focuses on how to use QML in large-scale application. The cool thing is with QML, you can quickly prototype something, and what we did is actually not only prototype, but extended it so that you can use it in large desktop applications. And the desktop is not dead. That's really true. Last cited this morning. And that's why we focus on here, and we will give you some ideas on how the QML is working in when you want to connect to the data, for example. This is really difficult if you only use the standard formats. As well, if you want to use the mouse in on your application, I mean, you need to get to work the tooltips or the drag and drop method. And as a good example, I show you how we created two-dimensional editor all within QML. And first, who are we? weplan. This is a company which has two parts actually. We are both experienced in real factory planning. So if you are a car company and you want to build a factory, we are there to plan everything from the logistics to the processes to the layout of the factory. And on the other hand, we are strong in the software world. We develop industry-leading software that is used to plan processes and logistics in a factory. It's used in the automobile sector in large companies. And we are located in South Germany, in Ulm and in Stuttgart. I am Helmut Sedding. I'm a lead software engineer, and the other guy here is Michael T. Wagner. He will present you tomorrow another great tool we developed to quickly create 3D scenes. You probably know QML 3D, which is only for Qt 5, but those who use Qt 4, those probably should have a look at SO declarative tomorrow at 11:30 in Moscow B over there. Okay, thanks. I already gave you a short overview about the talk. Now we'll start. I'll show you the software shortly. Okay, this is like the main window of our program. Here you get a 3D view of a factory. I only show you here a few stations in this example. And what you can do is run a simulation, actually. Now this was this application calculates all the worker paths. So the people that are working at the assembly line, they need to walk to the rack and then to the car and back and forth, and this all takes time. And to estimate the time, you can use the software, which all calculates it very quickly and makes realistic estimations. So this is essentially a Mercedes car here, and yeah, if you run the simulation, we can speed it up a little bit. So you see here the people working and walking around back and forth to the racks to gather material, for example. And you can slide here and let it run very quickly. Yes, this is we have all the workers that are doing stuff here. They you can see what they are doing if you have a look at the Gantt chart. Every worker is has listed its tasks here, and yeah, you can analyze and you can move stuff, and you can see, okay, what's here in the racks, what is in there. You can have a front view, and this is all QML on the top, and on the bottom it's the thing Michael Wagner will tell you more about tomorrow. So here we have QML views. Here this is a QML view of a product. I can zoom out a little bit. Here we got a table editor, all in QML. Here this Gantt chart diagram, and I click on a worker, you see his working over the time. I like the how many meters he's traveling. You get some bar charts, and the most sophisticated thing I think is the layout editor. Here you see all the factory floor from the top, and you can click here, and at the same time it is selected in 3D as well. So if I click on a 3D element, the selection is synchronized. So this helps the user to quickly understand what is happening here. And when I now drag it, you see it instantly moving in 3D. So this helps to quickly change a factory floor. And then I can calculate the paths again. So they now have to walk a little bit further. Yeah. Which is a bad thing usually, because then they are tired in the evening even more. So that's why we are helping to we are helping to make people healthy because they should not walk anymore, right? Yeah, and so because we often hear that people are tired in the evening because they walk too much. In some factories, they did not address this problem at all. So now we came with this software and analyzed it, and they were so, oh my god, he's walking like 20% of the time, and we should reduce that. Exactly, that's what our tool is for, and I now show you how did we do that actually, because it's all QML, and it's not a toy example, I think, but we run into certain obstacles as well, like how can we access all the data that is in the background. In the background, you see we have all the tasks that the workers are having to do. We see that the material is placed all over there. The racks, they are containing some boxes. You see the simulation results. You see some reports. All that is calculated in C++ because that is quick and safe. And the view is done in QML because that helps you to quickly show stuff tailored to the user. The user wants to see certain stuff only, not all data. So for example, as a simple starter, one needs to access simple values. For example, on the top you see an orange rectangle. It is rotated a little bit, and it's rotated by the angle the object tells us. And in the object we have a kube property, which is named angle as well, and it has a getter method and a setter method. So this not only allows us to read an angle, but also to write the angle. For example, if I click on it, I want to rotate it a little bit. So if I click, I set the angle to a new value, and interestingly, okay, the value gets to the setter, the member is changed, and then a notify signal is happening that is telling, okay, rectangle, please rotate again. So the notification goes to QML, and there the recalculation is happening. This is a very basic concept of QML, and we are using it all the time because it's so useful. You don't have to write update methods everywhere. It's basic subscription model. So everyone who wants to know the angle of the rectangle says, okay, I want to know that, and please tell me when it changes. So we can store everything centrally and have the subscription. And additionally, the group property macros help you to define your interface very clearly, because everything is clearly stated. The type is given, the getter, the setter, and if it's constant, you can write it as well. But there are certain disadvantages as well. If you want to instantiate a lot of those rectangles, every rectangle has to know, has to set up the signal connection for the notify signal. That takes time in the setup and tear down. If you just use const values, it's much quicker to do. But if you only do it on a small amount of objects, it's happening fast. One example of this, because this is quite important, I think. Okay, let's say we have a list of items, and the selected item should be marked with a cell. And when I click on another item, this item shall be normal again, and the other one shall be selected. It means I got a selected index stored centrally, and it's changing from 7 to 4. The first solution one could do is, on the mouse click, is change the central selected index, and in each text element we got a check, okay, is my index equal to the selected index? And if yes, we draw a different text here. So this is very quick to do in QML, but this is very problematic, because if I change now the selected index, and I got here thousands of those text items, every one of them needs to check, am I the new selected one? Am I the new selected one? So I need to go through all of you and ask you, but actually, if you see here, only 2 got changed. This one is not selected, and this one is selected. So actually, I need to change only 2 objects. And this is what we're doing here. We take the object that was selected before and set it to false, and take the new one and set it selected to true. So I get much less updates here. The difference is that I here have a constant value, and all the changing routine is done from the outside, which enables us to directly access the relevant items. So, but we did not do it in our application exactly this way. We coded all this in C++ to even make it much quicker, and to have a central selection model. So in our example, I can click here, and I click here, everything is synchronized. So all of those GUI elements react accordingly. I even got a multi-selection here, which I did not explain, but is straightforward to do as well. So if I select multiple elements, you see here, this is a list of all the selected elements. So it's all doable when you're doing the isSelected property. I mean, you can ask now, okay, where should this kube property go now? We got a base class QB object we use in all our data models. So it's inherited from the base class. So you define it once and you get it everywhere. All right. Yeah. Questions at this point? Okay. Well, so now to the next point. We got data models not only consisting of single objects, but we got loads of them. For example, here in table editor, you see it. We have a list of many objects, and each of those objects has many values associated to it. How can we do that in QML efficiently, both in C++ and in QML? Because our data models are in C++, we have a big application, so nothing with HTTP or something. We do it here in there. What possibilities are given to us by QML natively? First, we have the QList or the QVariant list. This is quite okay, but it does not enable us to do detailed repeater updating. What does that mean? So if we want to remove an element from here and add another at this list position, we need to recalculate all of our user interface elements. So if I got a huge list and I only insert one, it recalculates, it redraws everything. This is another requirement we have. We need detailed repeater updating. And what we also need is the possibility to pass a list as a function parameter over from C++ to QML and in the other way around. Okay, so but when we use the standard list models in QML, we cannot pass it to C++ because it's not made to be accessed from C++. So this is also not a solution for us. What comes nearest is the QAbstract list model. It has been in Qt for a while and is used in lots of places. But here, what I personally um, see as a larger problem, because we only use Q objects and not really values, we always need to cast it to a variant and back. And this variant container is a little bit overhead for us, and which makes our program not so efficient. So that's why we use the QObjectList model, which is a base, which uses the abstract list model as a base class, but provides the getters and setters for C++ directly. And because it's the base class of the QAbstractList model, it can be used in QML for all the repeaters. So this is a solution for both worlds. And yeah, you can basically download the QAbstractList model. It's publicly accessible in Bitbucket, or I will show you the link later. And what we also did is extend it a little bit to get type safety. If you want to compile it in C++, it's really good to have compile time checks. This is what we did when we introduced the template-based object-list models. Exactly. So when I now do it here in the graphical user interface, I, for example, change here a value. And you see instantly the value is changing in a list as well. So, and of course in 3D as well. So if I click here on something and change the value, you see it's changing in 3D and in a table view at the same time. In QML, to access the items is either via a repeater, or you can directly call the getter, which returns the QObject pointer. Or you can ask, what is the index, by the way? You can ask, okay, this object, is it in the list, and when, and if yes, at what position? You can ask the model, what is the index of an object with a certain name? And this usually goes linearly with the size of our list, but we extended the QObjectList model as well here to provide constant access times. In the background, an index is made, which is also updating if something is changing. And okay, any questions up to here? Okay, you're welcome to ask me. Okay, so another huge advantage of the QAbstractList model is it's mostly neglected, but it's very useful because it allows us to sort and filter data. I can click here on the header, and now all my data is filtered by the value here. So, or I can sort by this value and filter here. So I can do some filterings. And this is all done with Proxy models in the background. And while they are quite tedious to implement in C++, they are quite easily usable in QML, because we wrote a class that makes this accessible to QML. And I'll shortly show you how we did it, and because this will help you to do something similar for yourself. So how this works is first we got the original list, and then we got the list sort filter model, which basically filters out a lot of objects, so the list is smaller, and then sorts them so the positions get changed. And if now something is updated here in the original list, you will get automatic updates of the sorted, filtered model. So you don't need to call update manually. It's all done automatically. So how would you define such a model? You simply have a list sort filter name model. You assign a object list to it, and then tell, okay, then the name should be filtered by everything that starts with ABC. And it should not be case sensitive. And it should be sorted, but not by name. It should be sorted by birthday, for example. And then you can just reuse this in all your repeaters or whenever you wish to do. So you simply define a few lines of QML. You can process an input model and have some result. Okay, I showed you how you can filter by name, but I did not show you how can I do other filter expressions that are quite known in SQL by example. For example, if you have different sorting needs, filtering needs. For example, if you want to get only the objects that have a number below 100, this requires an expression that is evaluated. And we did that in JavaScript, so we don't need to write it in C++ again, which helps us again. The question is how bad that will hurt the performance. Actually, we did it with a list below 100 elements, and it's not noticeable at all. But if you have larger lists, I think it should be, yeah, you can always do it in C++. This is the advantage. So if you see, okay, this is too slow in JavaScript, I mean, you can quickly code it in QML in JavaScript, but if it's too slow, then you can always do it in C++. So this provides a safety net, basically. You can always fall back to that. But this here is implemented all in this kind of thing. So if I type, it comes instantly here. So basically, I think it should be sufficient for most of the needs. And here we have quite a lot of elements, but it's 500 or something. Yeah. So this function has a certain name, filter accept, which is called from C++, and then it returns a Boolean value whether it should be in the resulting list or not. We can do it similarly with sorting, with a less than function. So you define a precedence ordering for all your objects, and then you get the sorted list again. Okay, yeah, I think that's okay. The next point, proxy models in Qt are all about are proxy models, which last year I think there were 1 or 2 talks about. So you can easily do this in QML as well, which comes quite handy. You get an original data model, and you put it into a sorted one. You filter by name here, for example, and then you use this result as an input for the next sort and filter model. And here you filter by surname, and then you put it into one more, which just simply sorts the result. So you can chain all your results and reduce the list and sort the list in several steps behind each other, and is updated automatically. So if the first list changes, all the lists are recalculated, and you get the result. Yeah, quite handy. And so this also does not require lots of code. It's quite quickly doable in QML. This all provides you tools to to access your data, which is stored in C++, and you can access it from QML, which allows you to do applications that have a centralized data storage, which is not on a server, but all in memory. And you can use it both in C++ code and in QML, because it's transparently usable. The changes are quickly forwarded, and yeah, but you need to take care if you have lots of objects that are displayed because of the setup and teardown times of all the signals. When I did tests, for example, with the selection, with the naive solution, where the index is compared with the selected index, it takes, for 1,000 objects, it takes 50 milliseconds to recalculate. And if you do a direct access method, it takes 5 milliseconds. So it's like a tenth of the time. And if you got 10,000 elements, it's even a 100th of the time than the naive solution. Okay, any questions up to now? Well, yeah.
About the proxy model,
Mm-hmm.
are statically or dynamically created during runtime?
The proxy model objects are created by the QML runtime. That means dynamically. Um, Meanwhile, the properties they are also created dynamically, but the actual comparison whether an object is in there or not is done by compiled code. So you get the quick performance, but slightly longer setup times, which does not hurt you in a big application. You set up it once, and then you just let it run on the optimized C++ code. So you assign here, for example, the model, you have it assigned as a real pointer. So you don't need to, so when an update is happening, it's nothing in a JavaScript world. It all happens in a C++ world. The update handling, for example. Yeah. And no property call invokes and nothing. It's only there, right? Okay. Some more questions? Or does it answer your question? Yeah, okay. Thanks. So, up to the next part. What's the time?
15 minutes after 1, 30 minutes.
30 minutes remaining. Okay, thanks. 35. Mm-hmm. Great. So, to the next part, I showed you quickly the layout editor before, which is quite cool because you can scroll here, you can zoom, yeah, and you can move everything with the mouse, and it looks great as you would use a mobile phone. And this is what essentially drove us to use QML here as well. So how can one do that? I mean, this is really standard QML here. I had only a few custom elements used here. Essentially, this is a big Flickable, which is a QML element that allows you to scroll horizontally and vertically and put lots of items in it. And here we use the repeaters again with object list models in the background. So all our areas here, they are in a list, and they all have their position and their rotation, and there is selected property, for example. So it helps to have the object list model here in the background, and the data binding for the position and the rotation. And these are not only rectangles, we do have polygons here. So let me mess up this area again. So I can drag one of the edges, and it's a polygon. So, and this is not standard QML because QML does not support polygon drawing. Standardly, we used a Q graphics item implementation in the background, which draws with QPainter. By the way, you can also do this in Qt 5, where the drawer is the QPainter drawing happens in OpenGL automatically. So so first the repeater. So we got here the repeater, and we say, okay, all the recs should be drawn by this repeater. I can turn it on here. Now, with this button, all the recs are shown here in the layout editor. This light rectangles, and they have assigned the X and Y position and the rotation angle, and they have a certain size. So we deliver the bounds maximum and bounds minimum, and when we subtract it, we get the size of our rectangles. And yeah, it's simply positioned in the Flickable. Now you can ask, what about all the objects with a location? I mean, the Flickable expects everything to start at 0, 0 coordinate, whereas in our factory layout, nothing starts at 0, 0 usually. We had even a company that has lots of factories in Germany, but the origin is defined near Istanbul. So it would be a very long way to scroll manually. So that's why we have boundary calculations here. We use the children rect of all our elements and yeah, essentially do the offset computation here. The item x and y is minus this children rect x and y plus some border, so that nothing. So because we don't want to start everything at the screen edge, but with some offset. So the Flickable allows us to do that as well by doing an outer Flickable object and an inner item object that is offset a little bit. Okay, then how did we draw polygons? This is should be for you as an example how to do custom elements that draw themselves. You can not only draw polygons, you can draw your own images, you can draw animations, whatever is slow in QML or not implementable in QML. You can use graphics items there as you used to, as you were used to in Qt since years ago. So you can do the QPainter drawing, and what we also needed to do here is the hit testing with the mouse. For example, if I move over the mouse, it's really looking is it at the border of the polygon, and if yes, it goes to it enables to click us to make it selected. And for this, you also use the standard graphics item outline. You can define the outline, and what's in there is handled by the mouse. What's not in there is not handled by the mouse. So you essentially define a C++ class. You subclass it from the Q graphics item, and then you simply define your paint methods and define your mouse handlers. So it's actually very easy to do, and it's compatible with QML. So this polygon item is actually in QML code. It's simply let's see. So we have the areas. Oh, sorry. Polygon area polygons here. So we define a region polygon item. This is this looks like a QML item, but in the background is our own C++ item, and there we say, okay, the region of the polygon should be taken out of this object, and we have a zoom factor, for example, and this is all supported by our C++ item with according properties. So yeah, one moment. Yeah. So here in C++, you see here some properties defined, like the region and some other value. So this enables us to do this definitions. Okay. Yeah. Basically, we did it in Qt 4. And if you want to do it in Qt 5, you can do it, as far as I know, quite similarly. Because the QPainter, you can already, in Qt 4, you define it as a OpenGL painter. So you can look, taste how it will look like in Qt 5 later on.
For Quick 2, you probably have to use a QSG node rather than a graphics item.
Yeah, basically in Qt 5 there is a fallback method for doing your own items this way. But essentially true, in Qt 5 there is a new way of doing it, and but when it finally settles, it should be really similar, I think so, because you also define the properties of the objects, and you can simply add them to your QML world here. Okay, more questions to this? Okay. Well, okay. So I'm going to show you another usage pattern. Okay, often it is the case that if you need to edit elements, for example, here in the layout editor, we can edit the areas. We have some arrows here, we have some points to drag on here, we have the rotation thing, we even have lots of buttons down here to change text and whatnot. For example, if I change here the edge of the layouting, you see all the areas instantly moving to the other position. We want to be able to do that. And the naive solution would be to provide every area with edit object in QML as well. And if it's not selected, we simply hide it. So it's not visible and we can't edit anything. This is okay for small scenes. For large scenes, this is quite slow because every of those edit elements needs to be set up. And the problem, if you have the setup here, you don't need the edit items probably anyway. So what one can do is, and this is what we propose as a pattern, is the single edit component, which is basically one of those edit components, which is moved onto the area I currently edit. So I can switch the edited element. So I can, this is simply by clicking, the edit element jumps to the other area and displays the different properties. So here I have 2 now, and if I switch, everything is assigned instantly. And this is also made easy by the property binding QML provides in itself already. So you cannot only do this in the layout editor, you can use it everywhere, I think. For example, we used it here in our Gantt chart as well. So if I click on here on a process, we also get some edit controls here, and this is where we used it as well. In the code, it's essentially a loader and a component, and that is put into the component, and the loader tells which object should be looked on. Okay, right. Some questions to this? Mm-hmm. Yeah, okay, the question was whether the edit control needs to be on top, so in terms of a set coordinate on top of the other items. Basically, yes, and that is quite easy to do as well. You have a repeater of here of our polygons, and below in the QML code I have the loader. So it will be placed on top when drawing. And the component can be defined in another file, for example. Yeah. So does it answer the question? Okay, more about? Yeah. Okay. Well, to sum it up, the two editing, the Flickable element is working quite well. We can do really fancy scrolling. We can do zooming. We can do even content fitting, which I did not show. So I can click here. So everything is placed inside. So the zoom value is done accordingly. And another point is here, what we want to improve now is some level of detail rendering. If I am zooming out, you cannot read the names of the areas anyways. If I zoom in, they get too large. So I want to have some level of details. So, like for example, with this zoom level, I don't want the names. With this level, I want the names, but not too large. Yeah, for example. So or I even hide some elements. Exactly. I did a similar thing in the product display. For example, if I zoom in here, you see the pixels already. And if I zoom in even farther, it gets re-rendered. So there's a level of detail for the picture as well. So if I zoom in even further, it gets another image rendered, which gets quite large. But if I only want to look, it's only necessary if I really look close onto it, because it takes time to render. All right, and another thing which could be handled for a 2D editor is lazy loading, which we used in another area. So I mean, in layout editor, if I'm zoomed in and display very fine details now, I don't care about everything around which is not visible. essentially the same in the worker Gantt chart. What is not visible here, I don't need to render. So when we scroll here in the background, essentially the items are loaded and unloaded again. And we did this by checking what is visible. We have the content X and content Y properties, and this enables to check what is visible now. The list views are doing the same thing, essentially. No, you need to do it manually. This, yeah, exactly. List view does this automatically, but you see here as well, I scroll in two directions. List view enables to only scroll in one direction, either horizontally or vertically. For example, in the rack planogram, I can click on an area, you see here all the racks. If I scroll here, the dynamic loading, the lazy loading is happening automatically without me having to care about it. Only in a two-dimensional case, you need to do it manually. But you can do it. And I think this is a great property of QML, that everything is sort of doable. And in your last resort, you can always go to back to C++ again. I think this is a great message if you really want to develop QML applications in the large. You can always resort back to the fallback to the C++ type of drawing. Exactly. So does this answer your question? I think so. Okay, good. Okay, but we also have some limitation with the Flickable. The redrawing is happening too much. It has something to do with content-bound handling. So we're thinking about re-implementing it, but in Qt 5 there will be a Q scroller element with which is providing all the fancy scrolling stuff for standard Q graphics views in normal C++ Qt as well. So you can do it in standard applications. And maybe we are waiting, let's see. Okay, this is about the tool editing. Next point is if you want to really provide a desktop GUI applications, you need to do some stuff that is basically standard, but not provided in QML. If I go here on an item, and you will see a tooltip. And I mean, we basically had to do this ourselves, but it was doable as well. So for this, we wanted a really easy way to define tooltips. We simply declare here, for example, a button, and we set tooltip text what it does. And basically we implemented this as an attached property. So by setting this line, a new object is created, which is hung as a child onto the button object. So we have a tooltip attached object, which takes the button as a parent. And then you get the text property, where you can easily assign the text to. We also extended this to include components, so we can assign our own base class to it, which not only defines the isSelected property, but also tooltip methods. So this enables to do lazy loading here. But so the text does not need to be calculated all the time. I think the attached properties are mostly undervalued in QML here as well, because it's quite non-accessible mostly. And I think a disadvantage as well here is that you always need to create an extra object to attach some values to the original object. But it helps you to do certain things. I think you can also use those to do selections. If someone is interested, I got something for this as well here. Okay. So, yeah, 15 minutes, thanks. So next point. What we did here is you can take a box here and drag it somewhere else. So And this is even done with animations. So I can grab it, so and it sort of jumps out of the rack and put this box at some other place. And this drag and drop functionality is also something which is standardly not available in QML because it's a Windows drag and drop method. I can drag it even to another window or another application, which is, has been possible in QML since a while, but by QML. And for this, you find some extensions to QML, like basically some custom objects again that define drag areas and drop areas. For a drag area, I say, okay, it's basically like a mouse area. Let's say, okay, I fill it to the parent and say, okay, I can move this. When I click, an object is hung onto the data. And when I go onto a drop area, I can say, okay, I accept. I would take this box and then do some stuff with the data. As a data, you can define both text and objects, and to further handle more data, I said, okay, I want to simply assign the parent object, which is around and has lots of data values with it, so I can know where does this really come from. I can access the pointer and then access all the data again, like one is used to in standard QML already. Okay, so this means you can simply use the Windows stuff here, and if something is not possible, you can do custom items. You can even do custom QML items. You don't need to write C++ code all the time. You can make your own buttons, for example. But try to not include too many corner cases. For example, if you want to have a button that has at one time an image in it and at another time it has a text in it, don't make the decision within the button, but rather provide a text button and a separate image button, because it's so different within the code. One uses a text, another uses an image, and the image is positioned. And if you then create a lots of buttons, you would have both objects within, and one is invisible and one is visible. You don't want this overhead, that's why you simply create separate items. Now, what we also found out is that mouse input is basically all fine. So we can do tooltips, we can do drag and drop, and we can do even the scroll wheel. And but we did not use the right click because we want to be compatible to the touch interface. This is another advantage. If you have QML applications in, you can possibly use them again on some embedded device as soon as the BlackBerry or the Android implementations of Qt come out. Yes, what problematic I think is the keyboard input, because people are used to like press Alt N for to get to the text field of the name, and Alt B to jump to the birthday field. And as well, they are used to pressing the tab key to advance to the next field. I mean, this is possible to write in QML, but it's very tedious because everything has to be done very manually. Because, for example, if I have a field, I want to jump with the tab button to the next one, I need to manually set up all the pointers. So I think that is where the QML could be improved. But for most applications, I think this is not a hindrance. And what we also found out is that if you use list views, which are quite handy because they use lazy loading automatically, but if you add scroll bars to them, as most people expect scroll bars to exist in applications, you get problems when the item height is not fixed. So the scroll bar sometimes jump around a lot. Maybe I can show you this. If I scroll here, it's all fine. So, but if I draw over it, it's so okay. Now sometimes the scroll bars simply disappears. Sometimes hard to produce. Luckily, we got it fixed in most cases, but we are thinking about re-implementing another list view which allows for fixed height items. But still, it's doable. So I think you're not locked in a corner where you cannot get out again. Yes. I think that's for the technical part now. Any question here? Mm-hmm. Thanks. Mm-hmm. Essentially, the question was that in QML you don't get static compiler warnings, but only the runtime checks. That's definitely a problem if you change a lot, because then you always have to test if everything is working again, fine. But essentially, we coded the data model in C++, which enables us to use static checking. And in QML, it's mostly okay because it works. And you see that it works. You have instant feedback here. And if you have a look sometimes on a console, you find out, oh, I assigned a null pointer, but but it does not crash the program, which is quite cool, I think, and leads to another advantage in QML, because you don't need to recompile all the time. You simply start up your program, and we wrote a file watcher that's looking for all our QML files, and if a QML file is changing, we reload this QML view. So, I mean, if I change something here at the rec view, at the planogram, it only would reload this part, so I can really quickly develop my graphical user interface and test out, okay, is it better 1 pixel beside, or yeah. Mm-hmm. Yeah, exactly. So I essentially subclassed the QDeclarative view, and there, yeah, there's the file watcher. Yeah. So if there's interest, I think yeah. I think it won't be any problem to open source there. Yeah. Okay. Yeah, because it really speeds up development. Yeah. Oh, yeah, good questions. Yeah, good question. Once a student came and he said, "Oh, I did this in QML Designer." Yeah, but actually, I never used the QML Designer. I don't know why, but it never. Hmm? Yeah, maybe it's handy for the Photoshop users, so to do a quick prototype. But you're so quick in coding with Qt Creator, so you mostly don't need it's easy to do. It's like text and excuse me. What do you say? Mm-hmm. Ah, okay. Mm-hmm. Okay, so basically, you're telling me that in the he's telling us that in Designer it's hard to set up the bindings to C++. Yeah, I don't know about, but probably it's easy to. I don't know. I really recommend you to use Qt Creator because it enhances your developer experience, and yeah. Another question there could be, is it possible to use a debugger? Probably yes, but I never needed it. I simply, if something goes wrong, it's printed on a console, and I can, for example, I can write component on loaded, on completed. This is sadly not defined in a, so then I write console log. So you get very quick way of debugging here. And this is also possible on destroy and whatnot. So I think one really gets a feeling to the QML program world so quickly because it has a short development cycle. I can now save this and watch the result instantly. I think maybe it would be fun to do here as well. I run the debugged version, and then I could show. So the point in using QML in applications are for toy applications already is that animations look really cool and they are easy to create. You simply need to define animation elements, connect them to the right signals and the right properties, and write maybe a timer, and then it starts flurrying around. It's easy to change, as said. You can write really cool UIs. People are already used to having their mobile phone with a really nice UI designed for the real problem. And you can use the update routines with which allows for centralized storage. Yeah, but sometimes you got the disadvantage that you need to fall back to C++ because of some fine-tuning, which is not possible in QML. For example, if you have lots of elements that are almost the same, I cannot reference them. Like you're used in 3D scene graphs. I need to really copy the whole objects, deep copy, and I cannot say, okay, almost all is the same, only some properties are different. Another thing is the keyboard input is tedious. Yeah, and if I do the QObject list models thing, it helps me on a C++ side because I get type checking there, but not on a QML side. Yeah. Well, thanks for listening. I will really I would really be interested in people having similar experiences, like to talk about how did you develop your QML desktop application. We both are would be really open for any discussions about it. And then I will recommend the talk tomorrow about SO declarative, which enables you to do all the things you see, but in three dimensions. So basically, you can quickly create items that you can click on. You can quickly animate some cubes and some cones, or animate some other things. Yes. So I think we are finished now. Thanks for your interest.